Hi, this is Mr. Max. So today I am doing problems that you can solve using simultaneous equations, which means you get word problems and then you must form simultaneous equations to solve them. So I'm going to do a two-part video where the first part consists of 3 questions and the second part consists of 2 questions. Right, so the very first question here is about a spider. So if you read through the question, you see it says that the spider can walk at a certain speed and run at another speed. So we do not know the speed. If it walks for 10 seconds and runs for 9 seconds, it does a total distance of 85 meters. If it walks for 30 seconds and runs for 2 seconds, it then travels 130 meters. We need to find the walking and the running speed. Right, so I'm doing this normally, this question, I'll bring in a table like what I do here. Now, because I'm dealing with one part where it runs and another part where it walks, the speed is unknown, but the distance is 85 meters, and I put my units on top as you can see. And what you need to understand is that distance is always calculated by multiplying the speed times the time. Now, once we use the W and the R, I can create an equation. So my first equation will be the speed times the time here, that is 10 times W, because we don't know the speed that it was walking. So I'm using my W for walking. You could use X and Y, does not matter. And then I'm also adding that because I know the total distance is it's 85. I'm adding it to the second part where I multiply the time times the speed, but here I'm using R. That creates the first equation. So I'm going to have a second part where I do exactly the same. Multiply 30 times W plus 2 times R gives you 130 meters. So these are the two equations that we are going to solve simultaneously. So I would suggest that you pause a bit and have a look and see how I got to these. On the next slide, I'm going to then solve these two equations simultaneously. That means at the same time. Right, so let's bring the two equations back. So we are going to solve these two equations simultaneously. Now, it is very imperative that you use whatever method. I'm trying to make the coefficients of W the same by multiplying equation 1 throughout by 3. That means I'm going to multiply that 10W with 3. I'm also going to multiply the 9R with 3 as well as 85 so that I can have my coefficients for W to be equal, and then I can eliminate them. Right, so once I do that, I create sort of a third equation. I just tripled that equation. They are still equivalent equations. Bringing back equation 2, and now I'm going to subtract equation 2 from equation 1. And if I do that, obviously the W's will cancel. 27 minus 2 gives you 25. So 27R minus 2R is 25R. 255 minus 130 is equal to 125. So I'm putting brackets so you can know it's the whole equation that is being subtracted from equation 3. Solving for R should be very easy. 125 divided by 25 gives you R equals to 5. Now that you have R, you can now substitute into either equation 1 or 2. Okay, try to use the original equations. Well, I'm going to substitute in equation 1. That gives me 10W plus 9 times 5, which is 45, equals 85. And then I'm going to subtract that 45 from both sides of the equations, like so. That gives me 10W equals to 40. And then I'm going to divide throughout by 10. That gives me the walking speed of 4 meters per second. So the running speed, therefore, is 5 meters per second. Running speed is slightly more than the walking speed. Right, so I'm bringing in a second question. This one is about a car that travels at a steady speed of V kilometers an hour. We don't know the speed on a flat road. And then it covers a distance of S kilometers an hour in 2 hours. So we don't know the distance, but we know the time. And if the same car travels at a steady speed of 2V kilometers an hour, it covers a distance of S plus 5 kilometers in 2 hours. we need to find the value of v. So I decided to make a table where I can compare distance, speed, and my time. I know the times, 2 hours that it does in part 1, and also 2 hours that it does in part 2. Right, so remember, distance is speed times time. So if I have to find this distance here, I can create an equation that is 2 for this time times v. That gives me the distance of s. Right, simplify that, I'll just give you 2v equals to s. That is the first equation. The second part is take the speed times the time, which is 2 times 2v. That gives you 4v equals to s plus 5. Now these are the two equations that I'm going to solve, and I can solve this easily by just substituting 2v for s into equation 2. Alright, so that gives me 4v equals to 2v, now in the place of the s, plus 5. You can now easily solve by subtracting 2v from both sides of the equation, leaving you with 2v equals to 5. And 5 is the average of v, which is 2.5. So our v, the speed, is 2.5 kilometers an hour. Right, the third question here is, in 9 years' time, a mother will be twice as old as her son. 3 years ago, she was 4 times as old as her son. Find their present ages. Right, so let us use letters to represent the mother and the son. So I'm going to let the son be x and the mother be y. And what is important that once the question says in 9 years' time, you should know that is in the future. So you must add 9 to the age of the mother as well as the age of the son, because the age of the mother does not stop as the son is aging, and so also the other way around. And the second part, it says 3 years ago, that refers to the past. So you have then to subtract 3 years from both of their ages. So now it's just to get the other information in there, and I'm going to create the first equation, and you put the 2, the twice. The first part stays in 9 years' time. That's why I have x plus 9 and y plus 9. But I put my age for the son in brackets because twice the age of the mother, so you have to multiply the younger one, put that by 2, and you have to multiply that 2 with the x as well as with the 9. So once you do that, it cleans up nicely to an equation 2x minus y equals negative 9. And the second part that says 3 years ago she was 4 times as old as the son, so you have to put the 4 at the son's age again. Put that x minus 3 in brackets, and this one cleans up nicely also if you do it to 4x minus y equals to 9. That is after I have expanded the brackets and I wrote my equations in ax plus by equals to c form. Right, so bringing equation 2 and equation 1, I can actually eliminate by subtracting equation 1 from 2, because I can eliminate the y's. When the signs are the same, you subtract. Okay, so when the signs are the same, you subtract. Draw yourselves a nice line, eliminate the y's. That gives you 2x is equal to 18. Remember, 9 minus negative 9 is the same as 9 plus 9, which is 18. And half of 18 is 9. Okay, so that gives you already the age of the son. So you take this x equals to 9 and you substitute it into equation 1 or 2. You can use this ones here, all right, or you can use the original ones. It's totally up to you. So I'm going to substitute it into the second equation of 4x minus y equals to 9. That cleans up nicely to y equals 27. So the age of the mother is 27 and the age of the son is 9 years. Their present ages.